Okay, now we're going to move on to our vocabulary for a rigid motion. A rigid motion is a transformation that changes the position of the figure without changing the size or shape. Therefore, the distance between the points would need to be the same. So, very similar to how we do congruency. Let's say this is PQRA, and a transformation changes the position. So maybe we decide to flip it, turn it a little bit, or reflect it, and my new image is going to be here. And obviously the new images again are seen with the PQR. The lines are going to be exactly the same length. So PQ would be the same distance as, P prime, Q prime. QR would be the exact same length as Q prime, R prime. And PR would be the exact same length as P prime, R prime. In addition, the angles would be the same as well. So not only are these two figures congruent, but they also undergo a rigid motion. So when would a rigid motion not exist? Let's say you have the following triangle. And in this case, it's a dilation. Now, we're not getting into dilation at all really in this class. But a dilation is basically you're going to, like using a copy machine. If you've ever used a copy machine and you've asked the copier to like enlarge whatever you're printing to be 200% of the size, it becomes much larger, right? So let's say this is my image. I can tell that this is not a rigid motion because my new image does not have line segments that are congruent. So for example, AB is not congruent to A prime, B prime. So this is not a rigid motion because it doesn't have the same shape. Whereas down here, this one is a rigid motion. Okay? So let's try one example on this, and then you're going to try one as well. Use the coordinate notation to write the rule that maps each pre-image to its image. Then identify the transformation and confirm that it preserves length and angle measure. All right, so they've already given us both our pre-image down here in the bottom part and our image, which is at the top. So we want to figure out what's happening to get from this point to this point. So what rule is occurring? So we're kind of going a little bit backwards from what we did in the first example. So one thing that I noticed, I'm just really going to look for patterns that are occurring for every single point over here. P, Q, and R, how is it going to P prime, Q prime, and R prime? And what I'm noticing is that my X value, if I look at P and I compare it to P prime, let's only look at X's. I have -3 and -3. Let's look at my Q's. I have 3 and 3. And my R, I have 1 and 1. I want you to think about it. Does it look like my X's changed at all? Or are they the exact same value as the pre-image? They're exactly the same, right? All of my pre-image X values are exactly the same as the image X values. So in this particular problem, nothing is happening to my X. Okay? Now let's look at the Y values. So look at your P. My Y value is going from -1 to +1. Okay? Look at my Q. My Y value is going from -1 to +1. Let's look at R. My R is going from -4 to +4. So again, you're simply identifying the pattern. What do all of these things have in common? Now, some students might say, okay, well, I'm noticing on P that I go from -1 to 1, so maybe we're doing -1 plus 2 for my Y values. Wouldn't that work? -1 plus 2 is 1, right? So then I try that guess on my next problem. So is it going to be, Y plus 2? That's what we're guessing. And I do my next one, and I have -1 plus 2. That's also 1. But on my last one, I had -4. and I need it to equal positive 4, and that just isn't happening. So y plus 2 would be incorrect. So whatever rule you pick has to work for every single point. So think of it a different way. What is changing? I go from -1 to 1, and I go from -4 to 4. Isn't my y just changing signs? To go from -1 to +1, all I did was get rid of the negative, right? To go from -4 to +4, all I did was get rid of the negative. So how can I express that as an equation? Couldn't I just multiply my y by -1? So let's see if this works. If my p is -3, -1, and I undergo this transformation, my x would stay the same and my y would become positive. Let's try my r's, and sure enough, that's p prime, right? If I start with 1, -4, my 1 would stay the same and my y would become a positive. So because this rule works on all 3 points, I could try q as well, then that has to be the rule. So sometimes your rule is an addition problem. Sometimes it's subtraction. Sometimes it's multiplication, like in your last example. You just have to think what algebra is happening to the x, what algebra is happening to the y, and think of them as 2 separate equations. Now it's your turn to try one.